To start out, we are going to load in one of the included particle system presets. And since not very many of them have come with Vue, there's a few things you should know about this specific preset in case you've used it as sort of a template to modify your own particle systems. So there's a new button on the left, just above the ventilators, and what we can do is right-click to load a particle system preset. Basically, this is just an object, a VOB object, that has a particle ecosystem assigned to it. So from the particle systems, I'm going to load in the plane 2. And basically what this is a very simple smoke particle system. So F11 on the keyboard to open up the timeline, and we can start to scrub through. And we can see the smoke effect. Now, the smoke is being generated by sprites. If you're not familiar with sprites, they're basically 2D planes or slices of a 3D object in some cases, where you have multiple planes intersecting with one another to create a 3D looking material. In this case, the sprite is an alpha plane, and it is assigned to always face the camera. If I add an alpha plane to the scene, what we can do is you can load in the color picture and then the alpha to cut it out, the transparency. And then if you set it to billboard, it will always face the camera. So this is how the smoke objects have been set up, is with a plane like this with a smoke material assigned to it. Now, if you've examined this preset before, you notice there's a couple of different materials available, and that's because there's some hidden objects that look like they were not removed from this preset. So if you take a look in the material tab, there's two materials named default and then one called thick gray smoke. The thick gray smoke is a volumetric material, which volumetric materials do work within particles if you have them assigned to an object other than a plane or a flat object. But in this case, it's actually one of these default surfaces that is being displayed on one of the planes. So if we go to edit the material and take a look at the particle system, there's one object called Smoky. But if we turn off particle motion, we're going to find that there's a couple of different objects within here that actually aren't doing anything at all. So what we can do is delete the ones that are not actually part of the system anymore. It's possible that they were deleted from the particle system, but they still remained in the ecosystem population. So I'm pretty sure it's actually the bottom alpha plane that's being used. And if we go to edit the material, we can take a look at the current material assigned to it. And I'm pretty sure this is the right one, because the other one has a slightly different material, mainly the transparency. And no, that's not the one. So what we can do is select the alpha plane to the top one and delete it, and go to the sphere and delete it, and re-enable the particle motion. And that'll clean up this effector and this particle system object. So if you wanted, you could even resave it at this point and overwrite the current one you have, so that if you do want to load it in again, you don't have to worry about removing the extras that are part of it, because it's also going to load in other objects and materials that are not going to be displayed. So before we make any further modifications, I just want to kind of work you through what's creating the particles and driving them at this point. We're going to be customizing and creating our own setup and our own sprite object as well. That's going to look a little better than this one, and this one, I believe, is not entirely transparent on the edges, and that's going to cause render issues when you have a lot of particles in the scene. So because I turned off the particle motion and re-enabled it, the fast population mode was turned on. I am going to turn that off and recompute. More instances are generated when you have the fast population mode turned off. And from more advanced particle systems, I definitely recommend leaving the fast population mode off because things like functions assigned to alphas, uh, variable densities, and variable scaling, any sort of function control is not going to work when the fast population mode is turned on. So if we take a look in the particle motion settings, we can click Edit. What we're going to find is the animation range, which is set to auto at the moment. We have a domain length, so the area in which the particle system is effective. If we move beyond the area, let's say we move the camera beyond 1 kilometer from where this object currently is, the particles will no longer show up in the scene. They won't be calculated. The simulation rate is how many calculations are performed per second. It's a good idea to just generally match this up with the frame rate. Now the default frame rate for Vue is typically 25 frames per second. I'm usually working with 30, so I'm going to set mine to 30 hertz. And if you need more calculations for whenever you have very large particle systems, you can also bump that up to a higher amount to improve the accuracy of the particle creation. Now, the main driving forces at the moment is the gravity, which is reversed. The default would be negative 9.81, so that making objects fall, but because we have kind of a smoke system here, the gravity is set to 5, which makes the objects rise up. The drag force is essentially a wind or resistance for the object. We also have a turbulence setting. Lighter objects are affected more by the turbulence at higher values. The influence of ventilators and how strong all ventilators are going to impact this particle system. Whether or not the particles can be influenced by effectors. And then there's several other settings we'll be taking a look at too, but not at the moment. I do want to note that whenever you're working with sprites, avoid motion blur at all costs, because for the most part, motion blur doesn't work very well with sprites or completely flat objects. Okay, so besides the gravity raising these objects up, there's also the velocity setting. So we have the main force being gravity, or reverse gravity, at 5 meters per second. And then the velocity is 0.5 meters per second. And you'll see next to it that we have another box that is going to basically add and subtract the value that's put in to the first number. So in other words, if we have 0.5 for our main velocity and 0.5 for the plus and minus, what we're going to find is that we have variations between 0 and 1 because it's going to subtract up to 0.5 from the 0.5 setting from the main velocity and also add up to 0.5. Now if I remove these settings to 0, we're still going to have the objects rising up fairly quickly because primarily they're being influenced by the gravity. I'm just going to go ahead and set the velocity back. It doesn't have too big of an impact. Now the velocity can also be driven with a function. Once you do that, you're going to lose the variability that we have for the plus and minus, and you basically have to use object instance seeds in order to add the variability. The only major limitation with driving the functions and losing that is when you're uh, emitting particles from other particles. And we'll be taking a look at that a little later. And learning about some of the drawbacks. Now, the present setting is set to 33% because it was divided by 3 when the other 2 objects were in the ecosystem population. So I'm going to set the presence back to 100. It is not really going to have an impact on the amount of instances generated because it is the only instance. Okay, if we go to the density tab, what we're going to find is that we have an emission flow. So basically this is the amount of particles being generated per second, expressed as a percentage. Depending on the surface area you're working with, the emission flow is going to be a lot different than what you're used to working with for ecosystem populations, where values really end up reaching 0.01, 0.05 in order to get lower populations over large areas. And it's almost an exponential growth for the percentage. You can get some really high numbers in there. And that's mainly controlled by the scaling, which evaluates the surface area. So I've increased the density, and we can see more of that smoke object showing up. But only so much is really going to show on this area because the plane itself, if we take a look at the size, is only 55 centimeters. So it's quite small. If we were to increase the size of the plane, now it's going to fill in that new area. So that's almost always world-based, regardless of the mapping mode that you have set up for the material. So even though this is object parametric, it's not going to stretch out the evaluation area and increase particle sizes. It's going to reevaluate the normals, or the polygons that are part of the object, and emit from them. Now if we go back to the velocity, now this is by default set up for the direction from the normal, so along the z normal. If we go ahead and take this object, and I'm going to just add a little rotation to it, 30 degrees pitch. The velocity is going to be in the direction of the normal, and since we have such a low velocity, it's hard to tell right now. So I'm going to increase it to 4, and now we can see it going off along the z normal. If we switch our gizmo over to local mode, we can see the direction that normal is facing. So if we also drive this with a function, you'll find that we have the root emissions, which is a vector, and basically an exact orientation, direction along with velocity. And we're using the normal, the object normal, and connecting that directly so that we can emit from the surface. And using the multiply by constant, 0.5 I believe is the default. But we will lose our variability if we do that. I'm going to go ahead and right click to disconnect the function. You can just turn that back down for the moment. And if you want to see with a more complex object, or at least more varied object, what I'm going to do is replace this object, keep portions, and replace it with a sphere. So now we can see the velocity, it's extending outward more. going to go ahead and bump that up. So it's going to conform to the direction of the normal. And the orientation itself actually doesn't matter at this point since it is a sphere. But now we can send out the particles along those parts of the normal. Now we're just working with a regular population mode, but it is possible to turn on 360-degree population. In this case, we will see that we will emit from the object in all directions. And you kind of get a neat effect there. Once 360-degree population is enabled, you'll find that under scaling and orientation, the direction from the surface is set entirely to perpendicular. We can set it to vertical, and it doesn't make too many modifications to the way the velocity works. With billboards, it's a good idea to keep it set to vertical, or at least with camera-oriented sprites. Technically, the billboard object, or using an alpha plane as a billboard, allows you to use settings like the perpendicular option, also the rotation on any axis, and still have the object facing the camera, which is a little different than one of the other options of orienting sprites, and that is if we take a look at the particle options, go ahead and double click on this object, there's an option to always face the camera. Now we don't need to have this on because this is a billboard object. So it's always going to face the camera with or without this option. So now we're going to take a little look at how the scaling and the density affect the weight and the amount of particles being generated. For the most part, this is a fairly light emission, reaching 5 seconds, and we've hardly got any particles being created, and the density is almost maxed out. The reason for this is not only do we have a small object that we're using as the surface emitter, but also the scale of the billboard is taken into account. And if we double click on it, it's going to give us the mean size. And for the most part, this is actually kind of small. It's 43 centimeters. But the sphere is just a little over a meter. So it's going to evaluate basically how many of these objects it can fit onto the surface. And we've basically reached our maximum. So we have to decrease the overall scaling in this case. And then we're going to have to recompensate by adjusting the scale for the particle itself. Also under the mean size, you're going to find the mean density, which is basically the weight per cubic meter. So we set up the mass of the particle, and then variability if we want. But one thing I want to note is that whenever you have the size of an object change, it's going to modify its mass. So we have a variability in scale coming from two different options right now. One is this plus or minus option. So we're creating objects anywhere from 0.9 up to 1.1 because we're adding plus 1. So anywhere in between is the variability. Also, under scaling and orientation, we have a maximum size variation of 1. So we have a lot of some small objects and some large. There's a large amount of variability for the most part. And the smaller objects are going to have less weight. And then they're affected differently by the different forces within the scene. So basically, after we change this overall scaling, I'm going to bring it down to 0.5 and recompute. Generally notice a different impact on the way the velocity works on objects. For the most part, this actually seems to be staying relatively the same, but that's probably because the weight was fairly high to begin with. Or at least it wasn't in a range where it was reaching a point where it basically had no weight, which can happen when objects get really small. So we can see that the mean size has changed by modifying the overall scaling. So what we can do is put our scale to 2 and double it. So now we can have our particles at the same size they were before, but we can generate a lot more of them for the surface area. So what we do is we're basically decreasing the scale just for evaluation purposes in order to fill in the object more. And then we're going to just increase the scale overall to kind of fill them in. So it's an easy way to get higher density. Now another thing I want to note is that, as you can see, the particles are being deleted over time. There's two settings that are causing this. And for now, I'm just going to take my velocity to and turn it down to 2 and recompute. Actually, maybe 3. So we still have a little bit of that effect. If we double-click, there are two options controlling the lifespan. The main is, of course, in the Death tab, where we have life duration set to 2 seconds, and then plus or minus 0.1. So it's basically going to last around 2 seconds, and then it's going to delete itself. Another thing that is modifying this is if we go to the opacity variation, what we have is a change in the transparency, or the opacity of the particle, which is relative to the size variation. So the larger the variation in size, the larger the particle, the more transparent it's going to be. And once it reaches a certain level, it will be deleted at a certain percentage. With the altitude size variation, what we have is every meter there's an increase in scale, basically with a ratio of 1 to 1.2. Because if we go below a value of 1, we actually start shrinking particles rather than making them increase in scale. So that also works with the life size variation too. You could have it increase over time, and it does somewhat tie into the life duration. So that's an overall amount based on the life duration is the life size variation. So the default of 5 times, within its lifespan, it'll grow by 5 times. But if you set this value to 0, it will shrink down to nothing over time. So if we wanted these particles to last a little longer, the easiest thing to do is just increase the duration. I'm going to add an additional second. And depending on the opacity variation, that might not be enough, because most of them look like they're being deleted before even the 2 seconds that was set up. So what I can do is go to the Evolution tab and delete particles if opacity is, say, 3%. And now we can see all those other particles that were being deleted before returning to the scene. Now, you can make different changes with the opacity settings. So we could delete it at a higher value, like say 25%, and then we're going to have a lot of particles removed fairly quickly. So I'm going to bring that down to 3. Another thing too is you can control the final opacity amount. So it doesn't necessarily have to end on 0. If you don't want it to completely fade out, you just want it to fade slightly, you could raise this value. We could have it just go to 50%. Now, one thing I've noticed is if I type in 50, oh, it does look like maybe they fixed that. Nope. It reset that value to 0.5. So in order to get 50, we type in a value of 5,000, and now we get 50%. So you might just need to add 2 extra zeros in order to set this value, at least in the release I've got right now, and the majority of the first releases. But I am going to bring that down to 0, because that does work well. Now another option is the color variation. This is going to just add just a single color and vary it throughout the particles. So let's just pick something that's going to show up for now, and just do a cyan color. And it looks like it's acting as more as a subtractive amount. Probably because there's an overall color change. Oh, it doesn't look like there is. Looks like that has something to do with the transparency, I believe. Because if you notice, the preview object has blue in the background. It looks like it's almost using the material background color preview as when it cuts out the object. So if we also go to the color, you can see the variable color and the overall color amount is blue, but if we change this, it is going to drastically affect the particles. So in this case, at least with this object, it's acting as more of a subtractive. So we would have to go to an opposite value in order to make them more blue. I'm going to go ahead and just turn off the color variation. Now I also want to note that this size variation for the altitude scaling doesn't show within the preview in the OpenGL. You can see the preview in the render on the right, and of course when we render the frame. I'm just going to go ahead and just render this how it currently looks at the moment, and we can see the effect. And I did just cancel the render. It's taking an incredibly long time to render the opacity values. So I am actually going to go back and clip this out a little further. Because once it gets really large and it's really opaque, that's a lot of light calculations and ray tracing that needs to be done. So it should render a lot quicker now. And I did decrease the density just to get a quicker render. One thing you'll notice is with the altitude variation set up, as the velocity pushes objects downward, the particles will get smaller. So we see all those really small particles on the bottom. So if you don't want to use the altitude variation based setup, what we can do is just turn that off and have a variation over the life of the particle. And you could just try to raise that up until you get basically the equivalent of what you had before, or at least something close to it. I am going to, since I did decrease the density, and I do want to go back and just show you, because before I had the density fairly high. So if we take a look at the density at 89%, we've got 3,400 instances at the current frame. If I bring this down to 60 and repopulate, it brings it down to 3,000. If we go to 33, 2,700. So not very large changes. Once we start getting to about 10%, we're going to see a drastic change. So 10% is about half, which is why I was saying before it's kind of like an exponential amount. So basically 10% is half, or about half of 100% for the emission flow. And go down to 3, and then we're at 1,000. And I think it's around 2.5% or so that we can cut it in half again. And then if we really want less particles, we need to start bringing it down to, say, 0.2%, 1%. Even 1% is still 500. So it can be a little touchy, and you just got to kind of play around with it. And you'll get used to the changes, but for the most part, you'll find yourself for large particle systems using very small emission flow numbers. I'm going to go back and just increase the scale, which is going to change the range in the calculation area. And then we should be able to use a slightly higher density. And we have a lot more particles showing now because of the removal of the altitude variation. And here's just a preview render of how that currently looks. So what we're going to do now is create our own smoke particle, our own sprite object. I started with using some of the surfaces, mainly the transparency from this smoke object. So if we take a look at the material, using it as a base, the transparency, I did make a few modifications to it, and these texture maps are included with the training. One major thing that needed to be changed was the transparency production. With the way this is set up, around the edges, it's not entirely transparent. So since we have a square object, at certain points, depending on some of the settings that are enabled, mainly shadows, the intersections will show up in the render if you don't cut it out completely. So I did make a change to that. Right now, you'll also notice that shadows is turned off for this object. If you do want to have shadows turned on, you can re-enable that. It does take a little longer to render, and it does increase the chance of artifacts showing up within the render, especially with this sort of billboard setup, because of the way the rotation is assigned. So you can really see those squares now once we turn shadows on with this kind of a setup. So I'm going to show you how you can create a different kind of billboard that is going to eliminate a lot of these kind of artifacts. And this is partially caused by intersecting objects. It's also partially caused by highlights and the alpha setting, the backlight setting, just diffuse material diffusion in general. But for the most part, this is because of just the orientation of the objects and all the different intersections. We might be able to correct it in this case if I remove the rotation, the random rotation, and it looks like that still looks pretty bad. But the object we're gonna create is gonna look a lot better, and it's gonna be a lot more flexible. We'll be able to cast shadows with it and not have that horrible effect showing.